Hi, here we are discussing effect of potential on a photoelectric current. First we keep the plate at some positive potential with respect to plate C and illuminate the plate C with the light of fixed frequency nu and fixed intensity I1. Next vary the positive potential A gradually and note down the resulting photo current each time. It is found that the photoelectric current increases with increase in accelerating positive potential at some stage for a certain value of potential. You can see that there is no further increase in the value of photocurrent, so that we can say that photocurrent is reached at a maximum where there is no further increase in the photoelectric current value. So that means all the electrons that are able to reach the metal plate A, it is over. We can say that it is all the photoelectrons are emitted by these electrons reach the maximum value. There is no further increase. Now we say that this is called the saturation current, and the saturation current corresponds to a case when all the photoelectrons are reached at the collector plate. There is no further increase. And next we represent there is a negative retarding potential with respect to C. We are applying on the plate A, and it allowed to increase negatively, so that we can say that when we reverse the voltage, the number of photoelectrons reach on the other plate, metal plate A, that decreases. That means this negative value of potential just to oppose the, or which means the photo current or the electrons reached to the plate decreases due to the repulsion of this negative polarity. So now we know that a certain number of values that have a certain number of electrons that having maximum kinetic energy only will reach the metal plate A. So if we increase further in the negative side, we know that when there is a condition that that reaches, there is no further photocurrent, which means photocurrent becomes zero. That potential is known as minimum negative potential, or stopping potential, or cutoff potential. So cutoff potential is the minimum negative retarding potential V0 given to the plate A, for which the photocurrent stops or becomes zero, is called the cutoff or stopping potential. Now we know that all the electrons emitted from the metal do not have the same energy. So we can say that the electrons, number of electrons reaching the metal plate A may or may not be equal. So we know that when photoelectric current is zero, then this stopping potential is able to stop the highest kinetic energy photons, or highest kinetic energy electrons. That means this negative potential, this retarding potential is equal to maximum kinetic energy of that electron. So we assume K max is equal to E V0, where E V0 is the energy of the potential applied. So we can say that K max is equal to E V0. So this maximum kinetic energy is the value given here. Now we vary the intensities of photoradiation I2 and I3, so that we can say that I3 is greater than I2 is greater than I1. So in this case, you know that as intensity increases, the maximum saturation, the saturation current or maximum photocurrent also increases. So number of photons emitted per second is directly proportional to the intensity of radiation. But the stopping potential remains the same for all the incident radiation, whether it is I1, I2 or I3. So we can say that for a given frequency of incident radiation, the stopping potential is independent of its intensity. In other words, we can say the maximum kinetic energy of photoelectrons depends on light source and the emitter plate material, but is independent of intensity of incident radiation.